from here we can find out v. So we can write v will be equal to v naught cot of alpha. Now the vertical component of the final velocity v after time t. So we can see the vertical component of the velocity after time t. After time t, this will be equal to minus v cos of alpha, because it is in downward direction. Okay, next what we do, we use the kinematics equation specifically for the vertical direction. So we can say that for vertical motion, for vertical direction, we can write the equation of kinematics as Vy is equal to Uy plus Ay multiplied by t. So in this case, Uy, that in vertical direction initial velocity, is given as v naught sin alpha. Ay is equal to minus g, and Vy we already calculated, that is v cos alpha. So we put it, rather we can say minus v. So we put it here, we get minus v cos of alpha will be equal to v naught sin of alpha minus g into t. So now here we can find out value of t. So t will be equal to v naught sin alpha plus v cos alpha divided by g. And we already know the value of v. V is v naught cot of alpha. So we put it here. So this will be equal to v naught sin alpha plus v naught cot alpha into cos alpha divided by g. We take v naught as common, so we can write this as v naught divided by g sin alpha plus cot can be written as cos alpha divided by sin alpha. So we get this as cos square alpha divided by sin alpha. We can take sin alpha as LCM. So this will be equal to v naught upon g. We get sin square alpha plus cos square alpha divided by sin alpha. Sin square alpha plus cos square alpha is 1. So we can see that time is given as v naught divided by g sin of alpha. So this is the required time of flight, after which it becomes perpendicular. So this was our method 1. We can do it for method 2 also. So in method 2, let us draw the diagram. So in this case, what we consider, that this is the projectile in this direction, and v naught is its initial velocity, v naught, making that angle alpha. So we consider that let the x-axis is in v naught direction, so y-axis will be in this direction. So this is the basic thing which we consider. And similarly, the final velocity at this point is given as v. It will be making an angle of alpha with a vertical, and now we have shifted the coordinate, or we can say axis, x-axis as well y-axis. Now acceleration due to gravity will be also having its components. So this will be g, one component in this direction, another one in this direction, and we have this angle as alpha. So we get one component as g cos of alpha and another component is g sin of alpha. Okay, so there is only one thing which we said here, that considering we can write it here, considering x-axis along the initial velocity, which we already considered here. So we can say that after time t, the velocity is perpendicular to the initial direction. Okay, where initial direction basically means initial velocity direction. So it means, this means that Vx must be 0 after time t. So we are going to use the kinematics equation in x direction. So we can write v of x is equal to ux plus ax into t. So we already said that Vx will be 0, so we write Vx equal to 0 and Ux will be equal to V naught because initial velocity in x direction, and we are going to have A of x that will be equal to minus G sine of alpha. So we put here 0 is equal to V naught minus G sine alpha into t. So from here we can find out t. So t will be equal to V naught divided by G sine of alpha. This is the required time in which the initial velocity direction will be perpendicular. Next is, we are going to solve this by using third method. Third approach. In this case, we are going to use the slope of the trajectory. So let's draw the, once again. So we have initial velocity in this direction, V naught. So let us project it again. Angle is given as alpha, and it will be coming perpendicular, suppose in this direction. This is final velocity V, and it is going to have two components, and which will be Vx and Vy, and it will be making an angle of this angle, making of angle of pi by 2 plus alpha. Okay, and this is 90 degree. So we write the slope of the trajectory with respect to point of projection. So first we write slope of trajectory at point of projection. So let us call this as m1. So we can see that m1 is nothing but tangent of alpha. That's a basic slope equation, tangent of alpha. Next is slope after time t, slope of trajectory, after time t, after time t. Let us call this as m2, which is equal to tangent of alpha, and this can be written as dy by dx, and this can be further written as dy by dt divided by dx by dt. The rate of change of in y direction and rate of change of in x direction. This will be v of y upon v of x. Now using the kinematics equation, v of y will be nothing but v naught sine alpha minus gt divided by vx is v naught cos of alpha. This is our m2. Now it is given that both the slope are perpendicular to each other. Slopes are perpendicular. So we can write it as slopes are perpendicular. So this implies that product of m1 and m2 will be equal to -1. So we put m1 and m2. m1 is tangent of alpha. So we get tangent of alpha into v naught sine alpha minus gt divided by v naught cos alpha is equal to minus of 1. So if we solve this equation, we are going to get t is equal to v naught upon g sine of alpha. So it means this is the time after which the velocity vector is perpendicular to the initial vector. So it means same question, but it can be solved with the help of three methods, three approaches. Thank you.